methods. We can look at exercise 3I, question 11. And we want to show that equation has no real solution for any values of P and Q. So we want to show that the discriminant is less than 0, essentially. That's what I was telling you. Okay, so we need to find what the discriminant is. So the discriminant is given by B squared plus 4AC. B squared would be 2PQ squared, which is 4P squared Q squared. My minus 4AC. So 4P squared Q squared minus 4Q squared P squared plus 1. Factorizing P squared Q squared minus, we've got 4Q squared P squared minus 4Q squared. Okay. All right, let's see what we can do here. Guess what? We've got 4P squared Q squared. They cancel each other out. Great. We're just left with negative 4Q squared. Now, can you see the Q squared component of this expression is a perfect square, right? Perfect square. Now, perfect squares are always greater or equal to 0. Okay, that's all in good. So that's either 0 or positive. However, if we times that with a negative number, it's always going to be negative, because if we times a number that's always going to be positive or 0, and I times by a negative number, it's going to end up being negative no matter what. Okay, or 0. So since the discriminant equals negative 4Q squared, since Q squared is either greater or equal to 0, negative 4Q squared would always be less than or equal to 0. Okay, just by logic, if you wrote that, that's sufficient to prove that this is always going to be less than or equal to 0, simply because the perfect square itself is always going to be greater than or equal to 0. If I times the perfect square by a negative number, it's either going to be 0 or a negative number. So therefore, since your discriminant is greater less than 0, it must mean, so since discriminant would be less than or equal to 0, it must mean there's no real solutions. Okay, you write no real solutions because in specialists you do have solutions. They're called complex solutions. So we don't need to deal with that. You just say no real solutions. So hopefully it helps.